information and summarizing it. According to Salesforce's 2023 Generative AI Snapshot Research, 74% of generative AI users use it to distill complex ideas and summarize information. 26. Chapter 1, Introduction to Building AI Applications with Foundation Models. 17. I currently have over 40,000 photos and videos in my Google Photos. Without AI, it'd be near impossible for me to search for the photos I want, when I want them. For consumers, many applications can process your documents, contracts, disclosures, papers, and let you retrieve information in a conversational manner. This use case is also called Talk to Your Docs. AI can help you summarize websites, research, and create reports on the topics of your choice. During the process of writing this book, I found AI helpful for summarizing and comparing papers. Information aggregation and distillation are essential for enterprise operations. More efficient information aggregation and dissemination can help an organization become leaner, as it reduces the burden on middle management. When Instacart launched an internal prompt marketplace, it discovered that one of the most popular prompt templates is Fast Breakdown. This template asks AI to summarize meeting notes, emails, and Slack conversations with facts, open questions, and action items. These action items can then be automatically inserted into a project tracking tool and assigned to the right owners. AI can help you surface the critical information about your potential customers and run analyses on your competitors. The more information you gather, the more important it is to organize it. Information aggregation goes hand in hand with data organization. Data organization. One thing certain about the future is that we'll continue producing more and more data. Smartphone users will continue taking photos and videos. Companies will continue to log everything about their products, employees, and customers. Billions of contracts are being created each year. Photos, videos, logs, and PDFs are all unstructured or semi-structured data. It's essential to organize all this data in a way that can be searched later. AI can help with exactly that. AI can automatically generate text descriptions about images and videos, or help match text queries with visuals that match those queries. Services like Google Photos are already using AI to surface images that match search queries. 17. Google Image Search goes a step further. If there's no existing image match ING users' needs, it can generate some. Foundation Model Use Cases. 27. 18. Personally, I also find AI good at explaining data and graphs. When encountering a confusing graph with too much information, I ask ChatGPT to break it down for me. AI is very good with data analysis. It can write programs to generate data, visualize a tie-in, identify outliers, and make predictions like revenue forecasts. 18. Enterprises can use AI to extract structured information from unstructured data, which can be used to organize data and help search it. Simple use cases include automatically extracting information from credit cards, driver's licenses, receipts, tickets, contact information from email footers, and so on. More complex use cases include extracting data from contracts, reports, charts, and more. It's estimated that the IDP, Intelligent Data Processing, industry will reach $81 billion by 2030, growing 32.9% each year. Workflow automation. Ultimately, AI should automate as much as possible. For end users, automation can help with boring daily tasks like booking restaurants, requesting refunds, planning trips, and filling out forms. For enterprises, AI can automate repetitive tasks such as lead management, invoicing, reimbursements, managing customer requests, data entry, and so on. One especially exciting use case is using AI models to synthesize data, which can then be used to improve the models themselves. You can use AI to create labels for your data, loop ING and humans to improve the labels. We discuss data synthesis in Chapter 8. Access to external tools is required to accomplish many tasks. To book a restaurant, an application might need permission to open a search engine to look up the restaurant's number, use your phone to make calls, and add appointments to your calendar. AIs that can plan and use tools are called agents. The level of interest around agents borders on obsession, but it's not entirely unwarranted. AI agents have the potential to make every person vastly more productive and generate vastly more economic value. Agents are a central topic in Chapter 6. It's been a lot of fun looking into different AI applications. One of my favorite things to daydream about is the different applications I can build. However, not all applications should be built. The next section discusses what we should consider before building an AI application. Planning AI applications. Given the seemingly limitless potential of AI, it's tempting to jump into building applications. If you just want to learn and have fun, jump right in. Building is one of the best ways to learn. In the early days of Foundation Models, several heads of AI 28, Chapter 1, Introduction to Building AI Applications with Foundation Models. 19 smaller startups, however, might have to prioritize product focus and can't afford to have even one person to look around, told me that they encouraged their teams to experiment with AI applications to upskill themselves. However, if you're doing this for a living, it might be worthwhile to take a step back and consider why you're building this and how you should go about it. It's easy to build a cool demo with Foundation Models. It's hard to create a profitable product. Use case evaluation. The first question to ask is why you want to build this application. Like many business decisions, building an AI application is often a response to risks and opportunities. Here are a few examples of different levels of risks, ordered from high to low. 1. If you don't do this, competitors with AI can make you obsolete. If AI poses a major existential threat to your business, incorporating AI must have the highest priority. In the 2023 Gartner study, 7% cited business continuity as their reason for embracing AI. This is more common for businesses involving document processing and information aggregation, such as financial analysis, insurance, and data processing. This is also common for creative work such as advertising, web design, and image production. You can refer to the 2023 OpenAI study, GPTs or GPTs, allowed to it all. 2023, to see how industries rank in their exposure to AI. 2. If you don't do this, you'll miss opportunities to boost profits and productivity. Most companies embrace AI for the opportunities it brings. AI can help in most, if not all, business operations. AI can make user acquisition cheaper by crafting more effective copyrights, product descriptions, and promotional visual content. AI can increase user retention by improving customer support and customizing user experience. AI can also help with sales lead generation, internal communication, market research, and competitor tracking. 3. You're unsure where AI will fit into your business yet, but you don't want to be left behind. While a company shouldn't chase every hype train, many have failed by waiting too long to take the leap. Cue Kodak, Blockbuster, and BlackBerry. Investing resources into understanding how a new, transformational technology can impact your business isn't a bad idea if you can afford it. At bigger companies, this can be part of the R&D department. 19. Once you found a good reason to develop this use case, you might consider whether you have to build it yourself. If AI poses an existential threat to your business, you might want to do AI in-house instead of outsourcing it to a competitor. Planning AI applications. 29. However, if you're using AI to boost profits and productivity, you might have plenty of buy options that can save you time and money while giving you better performance. The role of AI and humans in the application. What role AI plays in the AI product influences the application's development and its requirements. Apple has a great document explaining different ways AI can be used in a product. Here are 3 key points relevant to the current discussion. Critical or complementary. If an app can still work without AI, AI is complementary to the app. For example, Face ID wouldn't work without AI-powered facial recognition, whereas Gmail would still work without Smart Compose. The more critical AI is to the application, the more accurate and reliable the AI part has to be. People are more accepting of mistakes when AI isn't core to the application. Reactive or proactive. A reactive feature shows its responses in reaction to users' requests or specific actions, whereas a proactive feature shows its responses when there's an opportunity for it. For example, a chatbot is reactive, whereas traffic alerts on Google Maps are proactive. Because reactive features are generated in response to events, they usually, but not always, need to happen fast. On the other hand, proactive features can be pre-computed and shown opportunistically, so latency is less important. Because users don't ask for proactive features, they can view them as intrusive or annoying if the quality is low. Therefore, proactive predictions and generations typically have a higher quality bar. Dynamic or static dynamic features are updated continually with user feedback, whereas static features are updated periodically. For example, Face ID needs to be updated as people's faces change over time. However, object detection in Google Photos is likely updated only when Google Photos is upgraded. In the case of AI, dynamic features might mean that each user has their own model, continually fine-tuned on their data, or other mechanisms for personalization such as ChatGPT's memory feature, which allows ChatGPT to remember each user's preferences. However, static features might have one model for a group of users. If that's the case, these features are updated only when the shared model is updated. 30. Chapter 1, Introduction to Building AI Applications with Foundation Models. 20. A running joke in the early days of generative AI is that AI startups are OpenAI or Claude wrappers. It's also important to clarify the role of humans in the application. Will AI provide background support to humans, make decisions directly, or both? For example, for a customer support chatbot, AI responses can be used in different ways. AI shows several responses that human agents can reference to write faster responses. AI responds only to simple requests and routes more complex requests to humans. AI responds to all requests directly, without human involvement. Involving humans in AI's decision-making processes is called human-in-the-loop. Microsoft, 2023, proposed a framework for gradually increasing AI automation in products that they call Crawl Walk Run. 1. Crawl means human involvement is mandatory. 2. Walk means AI can directly interact with internal employees. 3. Run means increased automation, potentially including direct AI interactions with external users. The role of humans can change over time as the quality of the AI system improves. For example, in the beginning, when you're still evaluating AI capabilities, you might use it to generate suggestions for human agents. If the acceptance rate by human agents is high, for example, 95% of AI suggested responses to simple requests are used by human agents verbatim, you can let customers interact with AI directly for those simple requests. AI product defensibility. If you're selling AI applications as standalone products, it's important to consider their defensibility. The low entry barrier is both a blessing and a curse. If something is easy for you to build, it's also easy for your competitors. What moats do you have to defend your product? In a way, building applications on top of foundation models means providing a layer on top of these models. 20. This also means that if the underlying models expand in capabilities, the layer you provide might be subsumed by the models, rendering your application obsolete. Imagine building a PDF parsing application on top of ChatGPT based on the assumption that ChatGPT can't parse PDFs well or can't do so at scale. Your ability to compete will weaken if this assumption is no longer true. However, even in this case, a PDF parsing application might still make sense if it's built on top planning AI applications. 31. 21. During the process of writing this book, I could hardly talk to any AI startup without hearing the phrase data flywheel. 22. Disclaimer, I'm an investor in Photoroom of open source models, gearing your solution toward users who want to host models in-house. One general partner at a major VC firm told me that she's seen many startups whose entire products could be a feature for Google Docs or Microsoft Office. If their products take off, what would stop Google or Microsoft from allocating 3 engineers to replicate these products in 2 weeks? In AI, there are generally 3 types of competitive advantages: technology, data, and distribution, the ability to bring your product in front of users. With foundation models, the core technologies of most companies will be similar. The distribution advantage likely belongs to big companies. The data advantage is more nuanced. Big companies likely have more existing data. However, if a startup can get to market first and gather sufficient usage data to continually improve their products, data will be their moat. Even for the scenarios where user data can't be used to train models directly, usage information can give invaluable insights into user behaviors and product shortcomings, which can be used to guide the data collection and training process. 21. There have been many successful companies whose original products could have been features of larger products. Calendly could have been a feature of Google Calendar. MailChimp could have been a feature of Gmail. Photoroom could have been a feature of Google Photos. 22. Many startups eventually overtake bigger competitors, starting by building a feature that these bigger competitors overlooked. Perhaps yours can be the next one. Setting expectations. Once you've decided that you need to build this amazing AI application by yourself, the next step is to figure out what success looks like. How will you measure success? The most important metric is how this will impact your business. For example, if it's a customer support chatbot, the business metrics can include the following. What percentage of customer messages do you want the chatbot to automate? How many more messages should the chatbot allow you to process? How much quicker can you respond using the chatbot? How much human labor can the chatbot save you? 32. Chapter 1. Introduction to Building AI Applications with Foundation Models. A chatbot can answer more messages, but that doesn't mean it'll make users happy, so it's important to track customer satisfaction and customer feedback in general. User feedback on page 474 discusses how to design a feedback system. To ensure a product isn't put in front of customers before it's ready, have clear expectations on its usefulness threshold, how good it has to be for it to be useful. Usefulness thresholds might include the following metrics groups: quality metrics to measure the quality of the chatbot's responses. Latency metrics including TTFT, time to first token, TPOT, time per output token, and total latency. What is considered acceptable latency depends on your use case. If all of your customer requests are currently being processed by humans with a median response time of an hour, anything faster than this might be good enough. Cost metrics, how much it costs per inference request. Other metrics such as interpretability and fairness. If you're not yet sure what metrics you want to use, don't worry. The rest of the book will cover many of these metrics. Milestone planning. Once you've set measurable goals, you need a plan to achieve these goals. How to get to the goals depends on where you start. Evaluate existing models to understand their capabilities. The stronger the off-the-shelf models, the less work you'll have to do. For example, if your goal is to automate 60% of customer support tickets and the off-the-shelf model you want to use can already automate 30% of the tickets, the effort you need to put in might be less than if it can automate no tickets at all. It's likely that your goals will change after evaluation. For example, after evaluation, you may realize that the resources needed to get the app to the usefulness threshold will be more than its potential return, and, therefore, you no longer want to pursue it. Planning an AI product needs to account for its last-mile challenge. Initial success with foundation models can be misleading. As the base capabilities of foundation models are already quite impressive, it might not take much time to build a fun demo. However, a good initial demo doesn't promise a good end product. It might take a weekend to build a demo but months, and even years, to build a product. In the paper UltraChat, Ding et al. 2023, shared that the journey from 0 to 60 is easy, whereas progressing from 60 to 100 becomes exceedingly challenging. LinkedIn, 2024, shared the same sentiment. It took them 1 month to achieve 80% of the experience they wanted. This initial success made them grossly underestimate how much time it'd take them to improve the product. They found it took them 4 planning AI applications 33 more months to finally surpass 95%. A lot of time was spent working on the product kinks and dealing with hallucinations. The slow speed of achieving each subsequent 1% gain was discouraging. Maintenance product planning doesn't stop at achieving its goals. You need to think about how this product might change over time and how it should be maintained. Maintenance of an AI product has the added challenge of AI's fast pace of change. The AI space has been moving incredibly fast in the last decade. It'll probably continue moving fast for the next decade. Building on top of foundation models today means committing to riding this bullet train. Many changes are good. For example, the limitations of many models are being addressed. Context lengths are getting longer. Model outputs are getting better. Model inference, the process of computing an output given an input, is getting faster and cheaper. Figure 1:11 shows the evolution of inference cost and model performance on massive multitask language understanding, MMLU, Hendricks et al., 2020, a popular foundation model benchmark, between 2022 and 2024. Figure 1:11. The cost of AI reasoning rapidly drops over time. Image from Katrina Nguyen, 2024. 34, Chapter 1, Introduction to Building AI Applications with Foundation Models. However, even these good changes can cause friction in your workflows. You'll have to constantly be on your guard and run a cost-benefit analysis of each technology investment. The best option today might turn into the worst option tomorrow. You may decide to build a model in-house because it seems cheaper than paying for model providers, only to find out after 3 months that model providers have dropped their prices in half, making in-house the expensive option. You might invest in a third-party solution and tailor your infrastructure around it, only for the provider to go out of business after failing to secure funding. Some changes are easier to adapt to. For example, as model providers converge to the same API, it's becoming easier to swap one model API for another. However, as each model has its quirks, strengths, and weaknesses, developers working with the new model will need to adjust their workflows, prompts, and data to this new model. Without proper infrastructure for versioning and evaluation in place, the process can cause a lot of headaches. Some changes are harder to adapt to, especially those around regulations. Technologies surrounding AI are considered national security issues for many countries, meaning resources for AI, including compute, talent, and data, are heavily regulated. The introduction of Europe's General Data Protection Regulation, GDPR, for exam PLE, was estimated to cost businesses $9 billion to become compliant. Compute availability can change overnight as new laws put more restrictions on who can buy and sell compute resources. See the U.S. October 2023 Executive Order. If your GPU vendor is suddenly banned from selling GPUs to your country, you're in trouble. Some changes can even be fatal. For example, regulations around intellectual property, IP, and AI usage are still evolving. If you build your product on top of a model trained using other people's data, can you be certain that your product's IP will always belong to you? Many IP-heavy companies I've talked to, such as game studios, hesitate to use AI for fear of losing their IPs later on. Once you've committed to building an AI product, let's look into the engineering stack needed to build these applications. The AI engineering stack. AI engineering's rapid growth also induced an incredible amount of hype and FOMO, fear of missing out. The number of new tools, techniques, models, and applications introduced every day can be overwhelming. Instead of trying to keep up with the constantly shifting sand, let's look into the fundamental building blocks of AI engineering. The AI engineering stack. 35. To understand AI engineering, it's important to recognize that AI engineering evolved out of ML engineering. When a company starts experimenting with foundation models, it's natural that its existing ML team should lead the effort. Some companies treat AI engineering the same as ML engineering, as shown in Figure 1:12. Figure 1:12. Many companies put AI engineering and ML engineering under the same umbrella, as shown in the job headlines on LinkedIn from December 17, 2023. Some companies have separate job descriptions for AI engineering, as shown in Figure 1:13. Regardless of where organizations position AI engineers and ML engineers, their roles have significant overlap. Existing ML engineers can add AI engineering to their lists of skills to expand their job prospects. However, there are also AI engineers with no previous ML experience. To best understand AI engineering and how it differs from traditional ML engineer ing, The following section breaks down different layers of the AI application building process and looks at the role each layer plays in AI engineering and ML engineering. 36. Chapter 1, Introduction to Building AI Applications with Foundation Models. Figure 1.13. Some companies have separate job descriptions for AI engineering, as shown in the job headlines on LinkedIn from December 17, 2023. 3 layers of the AI stack. There are 3 layers to any AI application stack: application development, model development, and infrastructure. When developing an AI application, you'll likely start from the top layer and move down as needed. Application development. With models readily available, anyone can use them to develop applications. This is the layer that has seen the most action in the last 2 years, and it is still rapidly evolving. Application development involves providing a model with good prompts and necessary context. This layer requires rigorous evaluation. Good applications also demand good interfaces. Model development. This layer provides tooling for developing models, including frameworks for modeling, training, fine-tuning, and inference optimization. Because data is central to model development, this layer also contains dataset engineering. Model development also requires rigorous evaluation. Infrastructure. At the bottom is the stack is infrastructure, which includes tooling for model serving, managing data and compute, and monitoring. The AI engineering stack. 37. These 3 layers and examples of responsibilities for each layer are shown in Figure 1.14. Figure 1.14. 3 layers of the AI engineering stack. To get a sense of how the landscape has evolved with foundation models, in March 2024, I searched GitHub for all AI-related repositories with at least 500 stars. Given the prevalence of GitHub, I believe this data is a good proxy for understanding the ecosystem. In my analysis, I also included repositories for applications and models, which are the products of the application development and model development layers, respectively. I found a total of 920 repositories. Figure 1.15 shows the cumulative number of repositories in each category month over month. Figure 1.15. Cumulative count of repositories by category over time. 38. Chapter 1, Introduction to Building AI Applications with Foundation Models. The data shows a big jump in the number of AI toolings in 2023, after the introduction of Stable Diffusion and ChatGPT. In 2023, the categories that saw the highest increases were applications and application development. The infrastructure layer saw some growth, but it was much less than the growth seen in other layers. This is expected. Even though models and applications have changed, the core infrastructural needs, resource management, serving, monitoring, etc., remain the same. This brings us to the next point. While the level of excitement and creativity around foundation models is unprecedented, many principles of building AI applications remain the same. For enterprise use cases, AI applications still need to solve business problems, and, therefore, it's still essential to map from business metrics to ML metrics and vice versa. You still need to do systematic experimentation. With classical ML engineering, you experiment with different hyperparameters. With foundation models, you experiment with different models, prompts, retrieval algorithms, sampling variables, and more. Sampling variables are discussed in Chapter 2. We still want to make models run faster and cheaper. It's still important to set up a feedback loop so that we can iteratively improve our applications with production data. This means that much of what ML engineers have learned and shared over the last decade is still applicable. This collective experience makes it easier for everyone to begin building AI applications. However, built on top of these enduring principles are many innovations unique to AI engineering, which we'll explore in this book. AI engineering versus ML engineering. While the unchanging principles of deploying AI applications are reassuring, it's also important to understand how things have changed. This is helpful for teams that want to adapt their existing platforms for new AI use cases and developers who are interested in which skills to learn to stay competitive in a new market. At a high level, building applications using foundation models today differs from traditional ML engineering in 3 major ways. 1. Without foundation models, you have to train your own models for your apply cations. With AI engineering, you use a model someone else has trained for you. This means that AI engineering focuses less on modeling and training, and more on model adaptation. 2. AI engineering works with models that are bigger, consume more compute resources, and incur higher latency than traditional ML engineering. This means that there's more pressure for efficient training and inference optimization. A corollary of compute-intensive models is that many companies now need more GPUs and work with bigger compute clusters than they previously did, which the AI engineering stack 39. 23 as the head of AI at a Fortune 500 company told me, his team knows how to work with 10 GPUs, but they don't know how to work with 1,000 GPUs. Means there's more need for engineers who know how to work with GPUs and big clusters. 23.3. AI engineering works with models that can produce open-ended outputs. Open-ended outputs give models the flexibility to be used for more tasks, but they are also harder to evaluate. This makes evaluation a much bigger problem in AI engineering. In short, AI engineering differs from ML engineering in that it's less about model development and more about adapting and evaluating models. I've mentioned model adaptation several times in this chapter, so before we move on, I want to make sure that we're on the same page about what model adaptation means. In general, model adaptation techniques can be divided into two categories, depending on whether they require updating model weights. Prompt-based techniques, which include prompt engineering, adapt a model without updating the model weights. You adapt a model by giving it instructions and context instead of changing the model itself. Prompt engineering is easier to get started and requires less data. Many successful applications have been built with just prompt engineering. Its ease of use allows you to experiment with more models, which increases your chance of finding a model that is unexpectedly good for your applications. However, prompt engineering might not be enough for complex tasks or apply cations with strict performance requirements. Fine-tuning, on the other hand, requires updating model weights. You adapt a model by making changes to the model itself. In general, fine-tuning techniques are more complicated and require more data, but they can improve your model's quality, latency, and cost significantly. Many things aren't possible without changing model weights, such as adapting the model to a new task it wasn't exposed to during training. Now, let's zoom into the application development and model development layers to see how each has changed with AI engineering, starting with what existing ML engineers are more familiar with. This section gives an overview of different processes involved in developing an AI application. How these processes work will be discussed throughout this book. Model development is the layer most commonly associated with traditional ML engineering. It has three main responsibilities: modeling and training, dataset engineer and inference optimization. Evaluation is also required, but because most people 40 Chapter 1, Introduction to Building AI Applications with Foundation Models. 24 and they are offered incredible compensation packages. We'll come across it first in the application development layer. I'll discuss evaluation in the next section. Modeling and training. Modeling and training refers to the process of coming up with a model architecture, training it, and fine-tuning it. Examples of tools in this category are Google's TensorFlow, Hugging Face's Transformers, and Meta's PyTorch. Developing ML models requires specialized ML knowledge. It requires knowing different types of ML algorithms, such as clustering, logistic regression, decision trees, and collaborative filtering, and neural network architectures, such as feed-forward, recurrent, convolutional, and transformer. It also requires understanding how a model learns, including concepts such as gradient descent, loss function, regularization, etc. With the availability of foundation models, ML knowledge is no longer a must-have for building AI applications. I've met many wonderful and successful AI application builders who aren't at all interested in learning about gradient descent. However, ML knowledge is still extremely valuable, as it expands the set of tools that you can use and helps troubleshooting when a model doesn't work as expected. On the differences among training, pre-training, fine-tuning, and post-training. Training always involves changing model weights, but not all changes to model weights constitute training. For example, quantization, the process of reducing the precision of model weights, technically changes the model's weight values but isn't considered training. The term training can often be used in place of pre-training, fine-tuning, and post-training, which refer to different training phases. Pre-training refers to training a model from scratch. The model weights are randomly initialized. For LLMs, pre-training often involves training a model for text completion. Out of all training steps, pre-training is often the most resource-intensive by a long shot. For the InstructGPT model, pre-training takes up to 98% of the overall compute and data resources. Pre-training also takes a long time to do. A small mistake during pre-training can incur a significant financial loss and set back the project significantly. Due to the resource-intensive nature of pre-training, this has become an art that only a few practice. Those with expertise in pre-training large models, however, are heavily sought after. 24 The AI Engineering Stack, 41. 25 If you find the terms pre-training and post-training lacking in imagination, you're not alone. The AI research community is great at many things, but naming isn't one of them. We already talked about how large language models is hardly a scientific term because of the ambiguity of the word large. And I really wish people would stop publishing papers with the title X is all you need. Fine-tuning means continuing to train a previously trained model. The model weights are obtained from the previous training process. Because the model already has certain knowledge from pre-training, fine-tuning typically requires fewer resources, e.g., data and compute, than pre-training. Post-training Many people use post-training to refer to the process of training a model after the pre-training phase. Conceptually, post-training and fine-tuning are the same and can be used interchangeably. However, sometimes, people might use them differently to signify the different goals. It's usually post-training when it's done by model developers. For example, OpenAI might post-train a model to make it better at following instructions before releasing it. It's fine-tuning when it's done by application developers. For example, you might fine-tune an OpenAI model, which might have been post-trained itself, to adapt it to your needs. Pre-training and post-training make up a spectrum. 25 Their processes and toolings are very similar. Their differences are explored further in chapters 2 and 7. Some people use the term training to refer to prompt engineering, which isn't correct. I read a Business Insider article where the author said she trained ChatGPT to mimic her younger self. She did so by feeding her childhood journal entries into ChatGPT. Colloquially, the author's usage of the word training is correct, as she's teaching the model to do something. But technically, if you teach a model what to do via the context input into the model, you're doing prompt engineering. Similarly, I've seen people using the term fine-tuning when what they do is prompt engineering. Dataset engineering. Dataset engineering refers to curating, generating, and annotating the data needed for training and adapting AI models. In traditional ML engineering, most use cases are close-ended. A model's output can only be among predefined values. For example, spam classification with only two possible outputs, spam and not spam, is close-ended. Foundation models, however, are open-ended. Annotating open-ended queries is much harder than annotating close-ended queries. It's easier to determine whether an email is spam than to write an essay. So data annotation is a much bigger challenge for AI engineering. Another difference is that traditional ML engineering works more with tabular data, whereas foundation models work with unstructured data. In AI Engineering, Data 42, Chapter 1, Introduction to Building AI Applications with Foundation Models. Manipulation is more about deduplication, tokenization, context retrieval, and quality control, including removing sensitive information and toxic data. Dataset engineering is the focus of Chapter 8. Many people argue that because models are now commodities, data will be the main differentiator, making dataset engineering more important than ever. How much data you need depends on the adapter technique you use. Training a model from scratch generally requires more data than fine-tuning, which, in turn, requires more data than prompt engineering. Regardless of how much data you need, expertise in data is useful when examining a model, as its training data gives important clues about that model's strengths and weaknesses. Inference optimization. Inference optimization means making models faster and cheaper. Inference optimization has always been important for ML engineering. Users never say no to faster models, and companies can always benefit from cheaper inference. However, as foundation models scale up to incur even higher inference cost and latency, inference optimization has become even more important. One challenge with foundation models is that they are often autoregressive. Tokens are generated sequentially. If it takes 10 milliseconds for a model to generate a token, it'll take a second to generate an output of 100 tokens, and even more for longer outputs. As users are getting notoriously impatient, getting AI applications latency down to the 100 milliseconds latency expected for a typical internet application is a huge challenge. Inference optimization has become an active subfield in both industry and academia. A summary of how the importance of different categories of model development change with AI engineering is shown in Table 1.4. Table 1.4. How different responsibilities of model development have changed with foundation models. Category building with traditional ML. Building with foundation models. Modeling and training ML knowledge is required for training a model from scratch. ML knowledge is a nice-to-have, not a must-have. A dataset engineering. More about feature engineering, especially with tabular data. Less about feature engineering and more about data deduplication, tokenization, context retrieval, and quality control. Inference optimization important. Even more important. Many people would dispute this claim, saying that ML knowledge is a must-have. The AI engineering stack, 43. Inference optimization techniques, including quantization, distillation, and parallelism, are discussed in chapters 7 through 9. Application development with traditional ML engineering, where teams build applications using their proprietary models, the model quality is a differentiation. With foundation models, where many teams use the same model, differentiation must be gained through the application development process. The application development layer consists of these responsibilities: evaluation, prompt engineering, and AI interface. Evaluation. Evaluation is about mitigating risks and uncovering opportunities. Evaluation is necessary throughout the whole model adaptation process. Evaluation is needed to select models, to benchmark progress, to determine whether an application is ready for deployment, and to detect issues and opportunities for improvement in production. While evaluation has always been important in ML engineering, it's even more important with foundation models, for many reasons. The challenges of evaluating foundation models are discussed in Chapter 3. To summarize, these challenges chiefly arise from foundation models' open-ended nature and expanded capabilities. For example, in close-ended ML tasks like fraud detection, there are usually expected ground truths that you can compare your model's outputs against. If a model's output differs from the expected output, you know the model is wrong. For a task like chatbots, however, there are so many possible responses to each prompt that it is impossible to curate an exhaustive list of ground truths to compare a model's response to. The existence of so many adaptation techniques also makes evaluation harder. A system that performs poorly with one technique might perform much better with another. When Google launched Gemini in December 2023, they claimed that Gemini is better than ChatGPT in the MMLU benchmark, Hendricks et al., 2020. Google had evaluated Gemini using a prompt engineering technique called COD at 32. In this technique, Gemini was shown 32 examples, while ChatGPT was shown only 5 examples. When both were shown 5 examples, ChatGPT performed better, as shown in Table 1.5. 44. Chapter 1, Introduction to Building AI Applications with Foundation Models. Table 1.5. Different prompts can cause models to perform very differently, as seen in Gemini's technical report, December 2023. Gemini Ultra, Gemini Pro, GPT-4, GPT-3. 5 Palm 2L, Claude 2, Inflection 2, Grok 1, Llama 2, MMLU Performance 90. 4% COD at 3279. 13% COD at 887. 29% caught at 32, via API, 70% 5-shot 78. 4% 5-shot 78. 5% 5-shot caught 79. 6% 5-shot 73. 0% 5-shot 68. 0% 83. 7% 5-shot 71. 8% 5-shot 86. 4% 5-shot, reported, prompt engineering and context construction. Prompt engineering is about getting AI models to express the desirable behaviors from the input alone, without changing the model weights. The Gemini evaluation story highlights the impact of prompt engineering on model performance. By using a different prompt engineering technique, Gemini Ultra's performance on MMLU went from 83.7% to 90.4%. It's possible to get a model to do amazing things with just prompts. The right instructions can get a model to perform the task you want, in the format of your choice. Prompt engineering is not just about telling a model what to do. It's also about giving the model the necessary context and tools to do a given task. For complex tasks with long context, you might also need to provide the model with a memory management system so that the model can keep track of its history. Chapter 5 discusses prompt engineering, and Chapter 6 discusses context construction. AI interface. AI interface means creating an interface for end users to interact with your AI applications. Before foundation models, only organizations with sufficient resources to develop AI models could develop AI applications. These applications were often embedded into the organization's existing products. For example, fraud detection was embedded into Stripe, Venmo, and PayPal. Recommender systems were part of social networks and media apps like Netflix, TikTok, and Spotify. With foundation models, anyone can build AI applications. You can serve your AI applications as standalone products or embed them into other products, including products developed by other people. For example, ChatGPT and Perplexity are standalone products, whereas GitHub's Copilot is commonly used as a plugin in VS Code, and Grammarly is commonly used as a browser extension for Google Docs. Midjourney can either be used via its standalone web app or via its integration in Discord. The AI engineering stack, 45. 26 Streamlit, Gradio, and Plotly Dash are common tools for building AI web apps. 27 Anton Bakaj told me that AI engineering is just software engineering with AI models thrown in the stack. There need to be tools that provide interfaces for standalone AI applications or make it easy to integrate AI into existing products. Here are just some of the interfaces that are gaining popularity for AI applications: standalone web, desktop, and mobile apps. 26 browser extensions that let users quickly query AI models while browsing. Chatbots integrated into chat apps like Slack, Discord, WeChat, and WhatsApp. Many products, including VS Code, Shopify, and Microsoft 365, provide APIs that let developers integrate AI into their products as plugins and add-ons. These APIs can also be used by AI agents to interact with the world, as discussed in Chapter 6. While the chat interface is the most commonly used, AI interfaces can also be voice-based, such as with voice assistants, or embodied, such as in augmented and virtual reality. These new AI interfaces also mean new ways to collect and extract user feedback. The conversation interface makes it so much easier for users to give feedback in natural language, but this feedback is harder to extract. User feedback design is discussed in Chapter 10. A summary of how the importance of different categories of app development changes with AI engineering is shown in Table 1.6. Table 1.6. The importance of different categories in app development for AI engineering and ML engineering. Category building with traditional ML building with foundation models AI interface less important prompt engineering not applicable important evaluation important more important AI engineering versus full stack engineering the increased emphasis on application development, especially on interfaces, brings AI engineering closer to full stack development. 27 The rising importance of interfaces leads to a shift in the design of AI toolings to attract more front-end engineers. Traditionally, ML engineering is Python-centric. Before foundation models, the most popular ML frameworks supported mostly Python APIs. Today, Python is still part03, Chapter 1, Introduction to Building AI Applications with Foundation Models. But there is also